may recall the law of conservation of energy, that energy cannot be created, it cannot be destroyed, but it can be transformed from one form into another. So we have different types of energy here. We have thermal energy, which is like heat, electrical energy, radiation, nuclear energy, kinetic energy, potential energy. And a simple one is, let's say you eat some chemical potential energy, in other words, food, and your body will transform that energy into thermal energy, which creates your heat, right? That's how your body stays warm, by eating food. Your metabolism, your body breaks it down and we turn that into heat. So you didn't create energy, you didn't destroy it, but you transformed it. Well, let's go back to our simple world of kinetic energy that we've been talking about. Let's say you have your phone and you drop it. So in other words, the initial speed is 0. But as it falls, you guys know that it accelerates. It gets faster and faster. And after 1 second, let's say it's going 10 meters per second, right? That's what we've said before. And I'm talking speed, not velocity. So it's just positive 10. After another second, which is, let's say, close to the ground, it's going 20 meters per second, let's say. Well, here, sorry, let's go back up here. Here it has 0 kinetic energy. Here it has some kinetic energy, which you would calculate mv squared over 2. You'd put the 10 in here and you'd put the mass of the phone, you'd have some positive number. And over here, you would have yet even more kinetic energy. 10 squared versus 20 squared down here, you're getting more and more kinetic energy as it falls. So we did not create that energy. We can't, according to the law of conservation of energy. Well, it's getting bigger, so obviously we didn't destroy it, but we can only transform it. And where that energy was transformed from, where it came from, is something we call gravitational potential energy. Gravitational potential energy. So just by taking an object, we took that phone and we placed it high off the ground, we have given it gravitational potential energy, which we can calculate. U means potential, and I've changed my mind about this subscript here. We're going to use capital G, but regardless, this means gravitational. Gravitational potential energy is equal to mass times G, which is 10, times the height at which you bring it. So we lift it off the ground 1 meter, H would be 1, and so on and so on. Oh, of course, let's write this down. So this is gravitational potential energy. All energies are in joules. This is the mass, which is in kilograms. G is 10 newtons per kilogram. Just is, and then H is the height. In meters. We will come back to mechanical energy. So let's do a quick example here. I've only got a few minutes here left. Jacinda, mass of 54 kilograms, stands on a bridge 321 meters above the ground. What is Jacinda's gravitational potential energy? Now, UG is one number. It's U is the number, G is just the subscript. Over here, this G is an actual number. So we'll say UG equals the mass times 10 times the height. And we simply run that through a calculator. 54 times 10 times 321. This is 173340 joules of gravitational potential energy. That's it. We have another example. Javier Sotomayor set the world record for the high jump. His gravitational potential energy as he made the jump, I'm talking about the highest point, is 1,970 joules. If Sotomayor's mass is 82 kilograms, how high did he jump? So we'll put in the gravitational potential energy, 1970. We'll put in the mass, which is 82. Put in g, which is 10, and we're trying to solve for his height. Well, we can just divide both sides, which is really just 820, but okay. We'll just do this calculation, which is 2.4 meters. Very easy calculations. Okay, I've got 5 minutes to show you this last one here. This is called mechanical energy. So if an object has, sorry, let me write this down. If an object has kinetic energy and gravitational potential energy, we could just add those two numbers up together to get the mechanical energy. So mechanical energy is simply the sum of kinetic and potential. And if one of those is zero, I mean, you still have mechanical energy. But let's do an example here. So this is kinetic energy, you all know. We really don't have to define these, but we already started. Everything is in joules. All energies are in joules. So a 128 kilogram droid is 2 meters above the ground and has 3,136 joules of mechanical energy. So question A, what is the gravitational potential energy, which is mgh? So we'll just do a quick calculation here. The mass is 128, g is 10, and the height is 2 meters. The gravitational potential energy is 2,560 joules. Question B, what is the droid's kinetic energy? So we're trying to find K. Now, if you remember this equation, all we need is the mass and we need the speed, but nowhere here, not even here, does it give speed. And so this is not going to be the way to solve for K. But if I know that the mechanical energy is the sum of kinetic energy plus the gravitational potential energy, I can use this as my equation to solve for K. And E is the mechanical energy is 3136. K we don't know. And UG we just calculated as 2560. And so we can subtract. Oops, to solve it. 3136 minus 2560. That's 576 joules is the kinetic energy. Now C, I have run out of time for, but now that you know the kinetic energy, we can use this one and work it backwards to solve for speed. That would be 576 equals 128 times v squared over 2. It's not going to be very pretty, but I can calculate this real quick. And you should try this. Oh, we get a really good number. So try out this math here, and you should get the speed is 3 meters per second. Sorry about that.